So what's the big deal with Docker or Kubernetes or Ansible Vagrant? You know, what are these terms? I've even heard of serverless. What's the deal with this? Let's have a chat. There's also software-defined networking and software-defined infrastructure. I mean, what are these things? How does it all fit together? Well, ultimately, these tools, Docker, Kubernetes, Ansible, Vagrant, they're really tools for managing configuration and the setup necessary to support an application. They come at it different ways, and it's really a little bit of an oversimplification, but they provide infrastructure that lets you scale and support an application. But even if you're running a very small application, it still makes sense to use these tools. And the reason for that is because it makes it easier to manage the project. Let me explain. So I'm kind of assuming that you're watching this video maybe as an explainer. Maybe you've done a little bit of work here. Maybe you've messed around with Docker, downloaded the community edition of Docker. And you've looked at this and it's like, this seems like it's kind of complicated. I just want to set up a web server. I just want to set up an application. And that's just apt install away for me to set up whatever this application is. And you're not alone in thinking that way. I mean, that's not technically wrong, but it's not technically right either. And it'll make more sense once we get into it. I mean, think about on any project that you've ever worked on. The people working on projects are terrible at documentation. Nobody wants to write down what they're doing. Nobody wants to write down why a decision was made. I mean, think about like the planning, the documentation that's done up front. Once the project starts, that documentation is never updated. And that's true for software projects, that's true for municipal projects, that's true for civil engineering projects. I mean, even when you're required by law to update the building plans, when somebody moves a bathroom or moves a wall, that only happens about 50% of the time when you're required by law. So imagine the Wild West of software engineering. It never happens. No battle plan survives contact with the enemy. Well, no software dev plan survives contact with the customer, or even really, past day one from implementation. So the most important concept, the most important thing to understand with these tools is that the idea is that you define what you need in a text file somehow. A manifest file, text file, a YAML, yet another markup language configuration file. And from that file, the automation kicks off and then gives you what you asked for, which might not be the right thing, but as you change that manifest file, it redefines what you get. So you don't just apt install Apache. Setting up an application is kind of a journey. It's like, okay, let me install Apache. Okay, let me go change some configuration. Okay, let me go whatever. Imagine this instead is like, whenever you get something wrong, you're immediately reset back to the step before you actually apt installed Apache. So apt install Apache is like, okay, now I need to configure SSL, download a file and do a thing. Whenever you get something wrong, you're all the way back to, okay, I've got to apt install Apache again and then do the configuration and all the other kind of stuff. That's basically what you have with a container, because a container, like with Docker and Kubernetes, is disposable. And so you tell the computer how you want it built, builds it, there you go. It's like baking a cake. Here's your recipe for making the cake. And if you're a really good chef, all the ingredients in the right proportion, and the baker is competent, you get, a nice, delectable, edible confectionery. But if you get the recipe wrong or you leave out the eggs, it doesn't work. Think about that from a project documentation standpoint. It's like, oh yeah, the lead developer had to add an extra egg because blah, 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 and we forgot to document that. And here we are 6 months later trying to scale it up, and it turns out the whole problem was that we were lacking an egg in a recipe we didn't know. If you use these tools, you don't have problems like that, because literally the file is the documentation for the stuff that you use, or it's pretty easy to do a one-to-one translation from here's this configuration file to here is the English textual language of what we did. It's way easier than digging around in the configuration of the running application. And also the meme of, works on my machine, all that sort of goes away. But at the same time, it's also kind of funny because we've somehow entered a world where copying an application to production is literally packaging up your machine, works on my machine, and running it in the cloud. So it's crazy, but that's where we are, and that's actually not a terrible thing, but it is funny to think about that way. Now you might say, but But Wendell, this is what you're describing. You're already off the deep end in terms of complexity. This is all way more complicated than apt install Apache. And I would say, young grasshopper, you do not know the depths to which you may have to go for Apache configuration. It is very deep and very broad, and you must learn many things about the rabbit hole of Apache configuration if you're setting up the Apache web server, for example. Now, out of the box, on most distros, the Apache web server is much slower than the Nginx web server, and that is mostly down to configuration. You can make Apache basically the same speed as Nginx with some configuration tweaks and some other stuff. And unless you get to the point where you know the Apache configuration and you know both products well enough, and you can look at like system call graphs in order to troubleshoot why something is slower than something else, or what's your expectation of fast and slow? Have you worked on enough machines to do that? You have to have a really sort of deep level of understanding, versus you have a container that some smart person on some Fortune 500 payroll has configured somewhere, and it is configured really well, way better than the out-of-the-box configuration that you get on most distros for speed or performance or whatever. There's different containers. You can pick different containers with different, goals. You can pick a development container that has all the development bells and whistles turned on to make it easier to do remote debugging or whatever it is that you need. But actually looking at how some of those containers are built, you can learn things. I learn things every day looking at that kind of stuff, like knowing where to look inside of that. You'd be surprised the insights you can take away from the notes that people have on things like high performance containers and the stuff that they've done to manage the performance there. And so if you use Docker or Ansible or other tools for doing that kind of automation, and you build your application with those Lego building blocks, you're going to be in a better spot in terms of performance and management than you are with the apt install method. And because the container forces you to separate the data and any configuration customization that you do for that container, it's sort of easy for somebody to come behind you and look at what you did, versus we've got a standalone web server, we've got a standalone database server, we've got a standalone whatever else, and I sort of have to, suss out what you did to configure the individual virtual machine versus the container, which sort of forces you to put your configuration and your data in a different place. At least if you don't put the data in a different place, as soon as Docker does something, the data evaporates and then it's all gone. You learn that lesson really quickly. So as your application grows in complexity and needs more than just a web server, it's got to send email, it's got to do all this other kind of stuff, there are different software components that you need to, do an equally deep dive on to be sure that your setup is the most robust and most secure possible. I mean, look at all the Amazon S3 buckets where they didn't even configure permissions. That's like the most, the lowest level, most baseline configuration that you do, and even then it's still hard to get right. Whereas if you do it with a container and you select the right base container to use for your application, a lot of those worries are taken away from you. The only common problem that I see is out of the box, you don't get log forwarding. I always want to forward the logs somewhere else, because those Docker containers, they have logging internally, but a lot of the time the logging doesn't go anywhere, or it goes to the Docker daemon, or it goes to Kubernetes. It doesn't go anywhere useful that you can actually keep an eye on it. And the problem is like, we've been hacked by the Chinese or the Russians. That's fine, just restart the container. And it blows away the container and rebuilds it, but doesn't necessarily fix the problem with how they got in there in the first place. And because of that, sort of normal cycle of delete everything and then reapply configuration to a new set of containers, delete everything, reapply to a new set of containers. I want to try this PostgreSQL container instead of this other PostgreSQL container. You end up with a more robust application because you're used to constantly sort of tearing down and rebuilding those containers. You don't have anything that is undocumented, basically, and it's the documentation falls out as a result of using the tool. That makes it worth the price of admission, because the documentation is never going to match reality otherwise. You're wasting your time if you think that will ever be true, really, because it's not. And if you're somebody that does software development, a little bit less on the system administration side, a little bit more on the software development side, there's a parallel set of tools that works pretty much the same way. Say, for example, you're working in the Laravel framework. It's a PHP thing. There's a tool called Composer. So you bring down Laravel and you do your stuff in Laravel. You're starting to do your custom code. You're managing your repository in a source code management tool called Git. Well, with Composer, you define a file that's all the open source stuff that you've cherry picked from the internet. You use Composer to say, go get me these things. And it builds a file that's all the stuff that you got from the internet. And then you also have your own custom code. So in your Git repository, you can store your custom code plus the Composer file. And then when you share the project with everybody, it's not this huge, messy, giant, insane, zip file of everything that you downloaded from the internet. Instead, it's just your custom code, so it's a lot smaller, more manageable, it's more awesome. And then Composer installs all the other stuff. It's the same thing. It's the same thing as Kubernetes and Docker and Vagrant and Ansible and all of that stuff. It's just a more developer-oriented version of the same idea as all of the other stuff. And in practice, once you learn those tools, your life is actually better. Like, there is less human suffering in the world as a result of these tools, even though it is the counterintuitive result, apt install Apache. That's real easy. You got me there. But ultimately, in terms of like total human suffering, that's pretty high on the total human suffering, managing that over the life cycle of whatever it is that you needed to apt install Apache for. Whereas with the container and the definitions, if you go through the trouble of setting it up on the front end, the total human misery is much less. That's why I like this. That's why I'm excited to make a video talking about this. And also we've got an upcoming project. So we've got those servers from Gigabyte. We're doing a project with VMware, and we're going to build a VMware cluster that's resilient and highly available. We're going to use a Synology NAS for iSCSI storage, along with a virtual flash cache. VMware is a cool product, and it's commercial and it costs money. There's not really features in the open source or free software segment that are really perfectly a feature parity. You can get close, jump through a bunch of hoops and with a bunch of configuration. We've got a project coming up with Synology, a sponsored project coming up with Synology, and I really think that there's something special in the VMware clustering, like the VMware vSAN products. It costs, but it's good. And so you can do some software-defined infrastructure with VMware. There are features in VMware that give you software-defined infrastructure capability. So you can set up recipe files that will call your VMware cluster and set up virtual machines. And you can actually set up a virtual machine running Docker, and then that sets up more Docker containers under that. But this is really cool for disaster recovery. This is really cool for data backup and restoring from a backup. It's also really cool in case you lose one server or a power supply or like a microprocessor explodes or whatever. Your VMs just keep running. Like the server that the VM was running on literally explodes without warning. And 5 or 10 seconds later, ever how long it takes your virtual machine to reboot, that virtual machine is back up and running with up to the minute data on another physical host. That is cool AF, I think. And we're doing it on big servers right now, but you can also do it on a Raspberry Pi. So I've also been doing this home automation series, and I found the best solution for home automation is actually to build a highly available cluster out of Raspberry Pis. So those are pretty inexpensive computers, but you're running Docker, and you're running this Docker container manager thing called Portainer, and Home Assistant, and a thing called Node-RED, and a whole bunch of stuff that I'm going to get into in another video. But that's how I have some of my really awesome home automation stuff. I mean, I've gone off the deep end with home automation. Like if the toilets run too long, or the dishwasher, a malfunction is detected in the dishwasher, like maybe the dishwasher is flooding the kitchen or something, it'll shut off the water to the house. The lights come on automatically when I get home. If it's after dark, they turn off, after dusk. They'll turn on again if they detect perimeter motion. The alarm for the house is set and unset automatically based on my presence, based on my arrival and departure. So home automation, you can do some really, really complex behaviors. I recently detected that my heat pump was short cycling, which means that the compressor comes on and doesn't stay on for very long and goes off. It's very hard on your compressor. It turns out that was because of a malfunctioning reversing spring or reversing valve. And I was able to catch that because I was so closely monitoring how the heat pump was running on this Raspberry Pi cluster. And so that saved me the cost of a new compressor, no doubt, because a reversing valve is actually pretty inexpensive fix, pretty easy fix, versus replacing your outdoor compressor on your heat pump. And it's just because I had these tools in place and this level of automation. Now, I went through a lot of work to set this up. I don't want to go through a lot of work to reset this up again. So backing this up and managing it and maintaining it is really important to me. And I've got that with these tools, which seems counterintuitive, admittedly. So while this complexity is a descent into madness, it's also the summit of simplicity. That's the paradox. Even for backup and restore, this really is the summit of simplicity. And yes, that is a bit of a paradox. Speaking of paradoxes, what about Amazon's serverless, Amazon Lambda, and other serverless infrastructure? Even VMware in some of their documentation, some of their white papers, they're saying, oh, look, you can do serverless. Serverless is kind of a lie. It just shifts where the manifest is. Obviously, you have to have a server, but what happens with Amazon Lambda, in a nutshell, is you just show up at the website with some code. I've written some PHP. You know, good sir, I would like to run my code when somebody does a certain kind of request. You just paste it into the browser or you use the API to upload the thing. You build an application by just running code. It doesn't make you think about servers or load balancing or EC2 or availability region. It doesn't make you think about any of that because Amazon is literally handling all that kind of automation that we're talking about on the back end for you. And it's packaging your code and probably thousands of other people's code and running it on an instance somewhere in a completely automated way, whether that's PHP or C# or Ruby or, you know, whatever language, you know, Node.js, whatever language you want to run, they're more than happy to run that on Lambda. And it's serverless in that you don't have to think about a server, you don't have to think about scaling, and you're charged per request. But under the hood, it's this same level of automation. And this same level of automation that we see with Amazon Lambda, that is 100% for sure going into the enterprise infrastructure, not just for web applications, but managing things like virtual desktop, managing your applications, managing high availability. And you can bet your bottom dollar that your server infrastructure, your Active Directory, machines, all of that is just going to be defined in a text file. I mean, yeah, you can point and click through the GUI in Microsoft Azure and Amazon AWS, but they also have very robust API interfaces. So once you have a recipe book or once you have a playbook, you can define a whole series of virtual machines and set up an entire infrastructure. Microsoft has point and click recipes for deploying Active Directory plus, you know, remote desktop, terminal services, whatever you want to call it, plus applications, plus shared storage, you know, plus my document redirection. You know, you just hit one button and you've got basically an enterprise infrastructure and it's set up, and you can, you know, it's got all kinds of really cool tweaks for it out of the box for security. Things like you can do multi-factor, things like, you know, banning login from impossible travel, things like automatically flagging Outlook emails that look like they're from somebody outside your organization. It's all automated. The documentation is literally, it's not just like a big PowerShell script that you paste in. It is a configuration file purpose-built and designed for this. And this is the future. So I think it's really cool that we're starting to see that kind of stuff built into VMware. And I'm going to do some videos using Synology appliances for the backing store along with Gigabyte servers for the storage. But I thought this was kind of an important video to get all this sort of thinking out of the way so that we can just, you know, play with the hardware, and I can refer back to this video and say, hey, remember when we talked about, you know, software-defined infrastructure and serverless, quote unquote, and things like Ansible and Docker and VMware and that kind of stuff? And it's like, oh, that's this video. So I'm wondering, this is level 1. There's been a little bit of a level 1 ramble. A little bit of something where it's like, maybe this could go on the Linux channel. Maybe this could stay here. But I thought it would be a pretty good introduction into a series of videos that we're doing. And it's also going to kind of tie into the home automation video that I'm doing, where it's like, hey, look, I can do this on a Raspberry Pi. I can run containers on a Raspberry Pi. And it makes it really easy to separate out the work that I've done from, you know, the millions of man hours of work that the people doing Home Assistant, Node-RED, and that kind of thing have done on their stuff. So, cool stuff. I'm Wendell, this is Level 1. As always, you're welcome on the Level 1 forums. If you have questions, comments, you built a system like this, or you just want to talk shop, I'm signing out, and I'll see you there.